short circuit results for phase star connected 1000 kVA 1905 volt 50 Hz alternator. It is a open circuit voltage. Values are given. It is in line. They already mentioned it is line. And short circuit current ISC it is given. And field current IF is given. Okay. The armature reactance per phase is 0.2 ohms. Draw the open circuit and short circuit characteristics and find the regulation of full load 0.8 power factor by using two methods. One is ampere turn, another one is synchronous impedance method. Okay, so ampere turns means the first method which we are going to solve, it is ampere turn method. This ampere turn method is another name called MMF method. Okay, MMF method. Okay, almost the steps everything is similar. Okay, synchronous impedance method is other name called it as EMF method. Okay, the whatever the procedure which we are discussed in EMF method, the same procedure only I am going to execute in MMF method. Okay, that's what I am directly taking the problem here. Okay, so in MMF method we have to first plot the value. Okay, we have to first plot the value. So it is star connected. Okay, what is star connected? V phase is equal to VL by root 3. Okay, so it is 1905 divided by root 3. So how much my V phase? Anyone? 1100 volt. 1100 volt. And the RA value it is RA. It is not reactance, it is a resistance. Sorry, it is resistance. Resistance RA equal to 0.2 ohm. And the power P equal to root 3 VL IL. Okay, so power value, how much power it is? 1000 kVA. 1000 into 10 power 3 equal to root 3 into this VL IL, all are phase. Okay, everything is phase voltage and phase current. Root 3 into VL phase, we already got it, right? 1100 into IL phase. So therefore IL phase how much more? What is the answer? IL phase, anyone? IL, this is line. This IL phase is nothing but IA phase. In star connected, line is equal to phase current. So how much? Anyone? Please give me the answer. IL how much from this? From this
524, sir.
5, it is 520. I got 303.05. Please check. 303.05 ampere. Since the machine
Sir,
is
524.
524.
Sir, it's 524.86.
Wait, 1 second. I will check it. 1000 into 10 power 3 divided by root 3 into 1905. No, I got 303.05, man.
Sir, here you have taken 1100.
Sir, you took 1100.
Oh, sorry. Here I have to substitute how much it is? 1905. 1905. VL, not V phase. sorry, mistake. Okay, in amount method we have to substitute line voltage root 3 into VLIL. Only all the terms should be in line voltage, line terms only we have to substitute. Okay, so root 3 into V line is 1905 into IL. So from this we can get 303.05. So since the machine is star connected, so when the machine is star connected, the line voltage is equal to phase voltage. Sorry, line current is equal to phase current. IF is equal to 303.07. Okay, now we can plot the parameters in our graph. Step 1. Step 1. IF.
Thank you so much.
This is IF. IF. This is 0. This one will be, the x-axis will be the field current, y-axis will be the open circuit voltage, VOC phase. Okay, now can you please convert all this parameter, because IF is 10. Okay, 10 means we can set the scale x-axis here. 1 unit is equal to 10 ampere. So 10, 20, 30, 40, 50, 60. Okay, 60. Then this 760, this open circuit voltage, it is in line. Now can you please convert this parameter into phase voltage? VOC line by root 3. VOC line by root 3. Can you please tell me how much for 760? So I can set the scale 200, 200, 400, 600, 800, 1000, 1200, 1400, 1600. Now convert the open circuit voltage line into phase voltage. Now how much it is converting? 760 divided by root 3, how much? What is the value we are getting? 760 divided by root 3. I am plotting open circuit curve. Okay, this is IF.
438.7.
Yeah. Wait. 10, 20, 25, 30, 40, 50. Okay, this is VOC phase by using VL by root 3. How much was 760? What is the value? 760 divided by root 3.
438.7.
438. 760 divided by root 3. 438.78 volt. For 1500 divided by root 3, it is 866.02, and 1700 divided by root 3, it is 981.49. 1905 divided by root 3, 1099.85. 2300 divided by root 3, it is 1327.9 volt. Everything we have to represent it in volt. Okay, 2600 divided by root 3, 1501.11 volt. Okay, now these parameters please plot. Okay, because now I am plotting open circuit characteristics curve. Okay, now plot it. So for 10, how much ma? For 10, anyone? For 10, where I have to plot? For 10 voltage, for 10 current, it is 438. 438 means, yeah. here, and for 20 it is 866. 866. For 25 it is 981. 981 means it comes around here. Okay, and for 30 1099. For 40 1327. For 50 1501. Okay, now join the lines. I'm using yellow color to join this line. Don't use a scale, please use only pencil. It should be curved. Okay, so this line will be open circuit characteristics. This is open circuit characteristics. Okay, now parallelly we have to draw for short circuit current. This line will be ISC phase. Short circuit current. Okay, this is short circuit current, and here you see the reading for short circuit current 220 135. So better I am fixing the scale 50 100 150 200 250 300 350 400. Okay, so to plot the short circuit, okay, to plot the short circuit, what I'm going to write here, sorry, it is moving. So for short circuit, to draw the short circuit curve, the x-axis IF, y-axis will be short circuit current phase. So IF will be 10 20 25 30 40 50. Okay, short circuit current is for 10 there is no value, for 20 it is 220 ampere, for 25 it is nothing, for 30 it is 335, for 40 nil, for 50 nil. Okay, now these two values we are going to plot it. Okay, so for 10 it is 0. Okay, 10 it is 0, and for 20 it is 220. For 20 it is 220 means where it comes 20 means this is 10 sorry, for 20 220 220 means here 220, and for 30 25 is nil, and for 30 it is 335. For 30 it is 335 300. Okay, now by using a scale, okay, by using a scale and pencil, okay, please take a scale and pencil, draw a straight line. I can't get a straight line by using my tab. Draw a straight line. The line should be a straight line. It should be a straight line. This line should be a linear line. Linear, and it should be straight. It should be straight line. Straight line from 0. Okay, this line will be short circuit curve. short circuit curve. Are you understand? Okay, now by using this short circuit curve, we are going to plot the I, IA phase, IA phase full load point. Okay, in short circuit curve we have to mark. So how much our IAC phase? It is 303.07. Okay, 303.07, 303 point here it comes around. Okay, and from this please draw a straight line. Okay, this line, this point will be 303.07 ampere. Okay, once you draw the line, then you project, it will be projected towards short circuit line, and it will be projected downwards. It is projected downwards from short circuit. So we will get this point will be 20. This point it comes around FAR. This point I call it as FAR. Okay, field, magnetic field, FAR. This point will be 27.5 ampere. FAR will be, FAR stands for resultant magnetic field in armature, 27.5 ampere. Okay, 27.5 ampere. Any doubts? Okay, now we have to find, okay, we have to find the V phase plus IA phase into RA cos phi. So what is the value? This one. V phase will be 1100, we got it, plus IA phase will be 303.07 into RA is 0.2, cos phi as per your question it is 0.8 per factor. We'll get 1148.5 volt. Okay, 1148.5 volt means 1148. This one, this is 1100. Okay, it will projected the short circuit curve. So from this line will be 1148.5. it will projected downwards. Okay, so this point will be F naught. It is 32 ampere. From graph, F naught equal to 32 ampere. Okay, generally in magnetomotive force field, that is in MMF method, there are two types of magnetic fields are produced. One, that is nothing but FR, resultant magnetic field is FR. FR equal to F naught plus FAR. These are the two magnetic field. One magnetic field F naught will be produced due to open circuit characteristics, and FAR will be produced due to short circuit characteristics. Okay, these are the two magnetic field, and these two magnetic fields will be basically depends upon the power factor. okay, which is basically depends upon this power factor. Okay. And I'm going to draw the phasor diagram. Please draw the phasor diagram. Take your scale. This is V phase. It is IA phase. IA phase, the angle between it is cos phi. Okay, it is phi angle, and it will projected towards this A point. A point means F naught. Okay, F naught will be projected, and it will be projected towards B point, and it will be P. We have to draw a resultant curve. It is FR. FR stands for resultant magnetic field, and this line will be FAR, armature magnetic field. Okay, and you have to close this line, close straight line and join it. Okay, this point will be C. The angle between it is phi. Okay, so this is the 0. This one will be the phasor diagram of EMF method. The EMF method is another name called, what is the EMF method is another name? It is a ampere turns method. EMF method is another name called ampere turns. Okay, why we are calling this ampere turns means this is the winding. So in the winding, when you apply the voltage, so based upon the force will be produced, lines of force will be produced, we are getting the flux. Okay, so this flux is nothing but a field line. Okay, so based upon the current, the flux will be produced. That is, if you apply the voltage, then only the current flows. Once the current enter into this number of turns, then only the flux will be produced. That's what this is known as ampere turns method. Okay, ampere turns method. This is a phasor diagram. So the final equation, FR equal to square root of formula. Because I am directly writing the formula, please follow my procedure. It is very simple. FAR into sin phi whole square plus FAR into cos phi whole square, square root of, how much my F naught? As per our graph, how much F naught we got it? What is the F naught value? Students, how much F naught we got it?
32.
32. Okay, it is 32. It is 32. Okay, 32 plus FAR, it is 27.5 into sin phi, how much? Because power factor cos phi equal to 0.8, so sin phi is 0.6 whole square plus FAR 27.5 into cos phi, it is 0.8. Now tell me the answer. What is the answer? Final answer. FR, resultant magnetic field. Please tell me the answer. FR. Anyone? How much answer, ma? FR? FR, what is the answer? 53.25. You got it? 53.25 ampere. You got 53.25 ampere. Anyone? Students? You got 53.25 ampere.
Yes, sir.
Okay.
Yes, sir.
Okay. Now this value plot in our graph sheet. Go to our graph, and this is field current. Okay, this F field current we have to measure only in where we have to measure. It should be measured in field winding. It is represent a field winding. Field. Okay. Field means current IF. Okay. So this 53 point it is 53.25. Okay. Please go here. It is 53.25. This point. This point will be 53.25. It is FR. This point is FR. Now what you have to do, please take your scale and pencil. Take your scale and pencil. Draw the line which face towards upward, which should be meet. Okay, which should be meet. It should be touch this open circuit curve. Okay, open circuit curve, it should be touch this line. Okay, so this FR you have to plot. Okay, you have to plot F naught FR. We have to plot field current IF versus field current versus VOC. Okay, VOC phase. Are understand? Are understand or not? This line is nothing but FR. It is 53.25 ampere. 53.25 ampere. Okay. Now go to our problem. Find the regulation. Okay. Find the regulation. Therefore, the regulation equal to E phase minus V phase divided by V phase into 100. Okay. So E phase how much ma? What is the E phase value? E phase, what is the answer? We got it. E phase, because if you projected it, if you project this upward direction, this line, okay, this point it comes around E phase. E phase will be E phase 1490 volt. Okay, 1490 volt you will get it. If you project it properly, you will get 1490 volt. Okay, so take down from the graph E phase equal to 1490 volt. Okay, from plotted from plotted or taken, we can taken from VOC phase, which is represented in y-axis. Okay, it is open circuit characteristics. Okay, open circuit characteristics. The FR we have to plot in IF scale. So the C phase will be how much? 1490 minus V phase how much ma? What is the V phase value? Starting stage we done. V phase equal to VL by root 3. 1905 divided by root 3. What is the answer? V phase? It is there. Starting stage we got it. Here.
So 1100.
1100. Okay. So this value substitute 1100 divided by 1100.
So 35.45%.
Good. Percentage regulation equal to 35.45%. Okay, understand? This is 35.45%. Okay, this is nothing but MF method. MF method, everything we are taking from graph only. Okay, we are going to take it from graph only. Okay, second method will be synchronous impedance method. Synchronous impedance method. The another name of synchronous impedance method will be, it is, what is that? EMF method. EMF, electromotive force method. EMF stands for electromotive force and EMF stands for magnetomotive force. So in this method, IA phase equal to ISC. So ISC is how much? Starting stage we done 303.07 ampere. The field current will be, IF will be 27.5 ampere. This 27.5 which we are taking from FAR. Okay, and VOC phase will be how much? My VOC phase, any idea? VOC phase 1490. 1490, but here I got it from the graph we have to take. Okay, from the graph we have to take. Okay, IF is 27.5. Okay, please go to your graph. How to calculate it? IF is 27.5. So for 27.5, please capture the VOC. For 27.5, please capture this VOC. For 27.5, this is your VOC point. For 27.5, VOC will be 1060 volt. Okay, from the graph take down everything. I am calculating from the graph only. VOC equal to 1060 volt. Okay, this value we have to taken from graph y-axis VOC phase. This we have to take it from open circuit characteristics. Okay, with respect to versus IF equal to how much? 27.5. For 27.5, you have to measure this VOC from the graph. Okay, from the graph. Understood? Now ZS is equal to VOC phase divided by IA phase. VOC phase will be 1060 divided by IA phase will be 303.07. It is 3.4975 ohms. This is ZS. Okay, and XS equal to square root of ZS square minus RA square equal to 3.4918 ohms. Okay, 3.4819 ohms. Now in EMF method, what is our formula? E phase formula. E phase is equal to square root of V phase cos phi plus IARA whole square plus V phase sin phi. Since we are measuring for Lagging or leading? It is lying. As per your question, it is lagging per factor. We have to put plus symbol. Plus IA xs whole square. Now substitute the parameters. Equal to V phase 1100 into cos phi 0.8 plus IA 303.07 into RA is 0.2 whole square plus V phase 1100 into sin phi, it is 0.6 plus IA 303.07 into XS 3.4918. Can anyone tell me the answer? How much? What's the answer? E phase, final answer. E phase is equal to, I got 1958.87 volt. Okay. Now what is the next step? We have to find regulation. Same regulation formula. Percentage regulation is equal to E phase minus V phase divided by V phase into 100. Now substitute it. V phase how much? 1958.87 minus V phase value, it is 1100 divided by 1100 into 100. What's the answer? Anyone? Please.
78.04.
70.
8.07.
Good. 7% regulation is equal to 78.07%. This is my final answer. Okay. So please, again, I will upload this video in your Google class link as well as the material also. Please listen, watch this video properly and do some practice.